We work on experiments all the time at the Louis Armstrong Middle School. We have recorded some of our experiments for students to review.
So right now we are taking the temperature of water, air, sand from the beach, and dirt from the Mojado Desert.
Air.
I said air.
Oh, my bad.
Sorry.
Could you believe it's air?
We're supposed to be holding this.
Air.
We're supposed to be holding this for 3 minutes, and right now we're at about a minute 50.
We're going to 2 minutes.
Then we need to go to 3. Okay, so I guess we're gonna get back to this one.
Our goal in this experiment is to see whether different materials on the Earth heat up the same when exposed to heat, and over time whether or not those materials, after heated up, will keep their heat after it becomes dark. We're going to take these materials, soil, sand, water, and air, and expose them to a heat lamp for 15 minutes, taking the temperature every 3 minutes. At the end of 15 minutes, we're going to turn the lamp off and continue to take the temperature every 3 minutes. We have a timer set, so we're going to put our timer on. And we're starting our timer, and we're turning our lamp on. Our thermometer reading for air is at 28 degrees. At start, our thermometer reading for soil is 28. It's 28 for sand, and it is 23 degrees for water. So far, 1 minute has passed. The temperatures are beginning to rise. The temperature of the air right now is gone up to 30. The other temperatures are still under 30. Okay, we are at our 3-minute mark. The temperature of the air has gone up to 35 degrees. The temperature of the soil has gone up to 30. The temperature of the sand has gone up to 30, and the temperature of the water has gone up to 25 degrees. Okay, we are at our 2-minute mark, and the temperature of the air has gone up to 38 degrees. The temperature of the soil has gone up to 32. The temperature of the sand has gone up to 32. And the temperature of the water is staying at 25. Our equipment consists of this heat lamp attached to a ring stand with a clamp. We have a basin or tray with 4 small plastic containers. In these 4 plastic containers we have air, water, sand from the beach, and soil from the park across the street. Our thermometers are Celsius degree measuring thermometers made by Delta Education. Our heat lamp simulates the sun and is remaining on for 15 minutes. We're almost at our 9-minute mark, which will give us our 3rd reading today. Okay, we are at the 9-minute mark, and this is our 3rd reading. The temperature of the air is at 40 degrees. The temperature of the soil is at 33 degrees. The temperature of the sand is at 35. And the temperature of the water has gone up to 37. It's important not to touch the thermometers as their body temperature is 98.6 degrees, and this will cause the thermometer's temperature to rise just because you're touching it. This will cause a variable in your experiment. We have about another 50 seconds until we reach our 6-minute mark. We're going backwards in time, counting backwards from 15 minutes. "23 more seconds to another reading." Okay, at our 6-minute mark, we're taking another reading. The temperature of the water has gone, of the air I mean, has gone to 41 degrees. The temperature of the soil has gone to 35. Temperature of the sand has gone up to about 38 degrees, and the temperature of the water has gone up to about 28 degrees. Are all the materials or mediums, air, water, sand, and soil, heating up at the same rate? Are some of them heating up faster? Are some of them getting hotter than others? Notice that the mediums or materials are not the same. Take a good look at the soil. Notice the consistency. Take a look at the sand. What about the particle size? Are they similar? What about the color? And air. In what way is air different from the other two materials? And water. More than 75% of the earth is made of water. In what way does water help in the heating of the earth? Well, we're almost down to the 3-minute mark. We're getting another temperature reading, another 30 seconds. Okay, so at that 3-minute mark, we have the air registering a temperature of 40 degrees. We have the soil measuring a temperature of 37 degrees. We have the sand measuring a temperature of 38 degrees. And we have the water measuring a temperature of 28 degrees. The next reading will be our final reading with the light on, and then we will turn the light off. This will be in about 2.5 minutes. What are your predictions about when the light gets shut off? We can see that one material seems to be heating up faster than the others, but will those materials retain their heat the same? Will the air hold on to its heat the longest, or will it cool off the fastest? Will the sand hold on to its heat the longest, or will it cool off the fastest? And what about the soil? And then again, what about the water? Or will all of them cool off? Or will all of them just retain the same amount of heat for minutes and minutes and minutes? We will soon see. In 1 minute and 11 seconds, we'll shut off the light after we've taken our last reading, and then continue to take readings every 3 minutes. Well, it's almost time to turn off our light, and it's time for our last temperature reading. It seems that the air has gone up to a little bit past 40 degrees. Our soil seems to be about 38 degrees. Our sand seems to be about 40 degrees. And our water seems to be up to about 39 degrees. So now we're going to turn our light off. And we're going to take the temperature every 3 minutes for approximately another 2 minutes. Now this information, or this data that you've been collecting, can be put onto a graph. But since you have been collecting the data from 4 different mediums, it'd be important to be able to tell the difference between the lines on your graph. How will you do this? Will you make all 4 lines on your graph the same color? Should you make the lines in different colors? Should you have a color key to tell which line stands for water, which line stands for air, which stands for sand, and which stands for soil? The object of the graph is to make your data easier to understand, not more difficult to understand or more difficult for you to present your data to others. Well, 1 minute has gone by with the light off, and already I'm noticing that the air and the soil have started to go down in temperature, but I'm not giving you a temperature reading yet. 1 minute and 20 seconds have gone by. Okay, in about 25 seconds I'll be taking this temperature reading. Okay, 3 minutes have gone by and the temperature of the air is 32 degrees and the temperature of the soil is 35. Temperature of the sand is 38 and the temperature of the water is 28 degrees. Okay, in 2.5 minutes we'll be taking our last temperature reading for this experiment. Yeah, 1.5 minutes. And 48 more seconds to our last temperature reading. Twelve seconds. Okay, and this is our last temperature reading. The temperature of the air is at 30 degrees. The temperature of the soil is at 35. The temperature of the sand is at 35. and the temperature of the water is at 27 degrees. So, which of them heated up the fastest, and which of these mediums was able to retain the amount of heat they absorbed the longest? We hope you enjoyed your experiment with us today, and we hope you come back and do other experiments with us in the future. Have a great day.